Hi everyone. Here we are back at number 3 of this week's practice. We're asked to perform an operation multiplying on two rational expressions. So when we go through this, when we multiply fractions, top times top, bottom times bottom. So I have this problem on another sheet of paper. We'll go ahead and look at it right now. So before we dive into this, if we want to multiply this, we're going to reduce a whole bunch of this before we actually multiply. If we make up some other random problem right now, so say we want to do something like 2/12 times 4/8. We could go ahead and multiply 2 times 4, 12 times 8, and go on our way and reduce from there. But if we notice there's common factors beforehand, we can reduce, and this is where cross cancel came up, but we're actually just reducing common factors out of this. So how we would actually do this is you'd reduce 2 and 8. You'd say, well, this is 1 and 4, and you'd reduce 4 and 12, and you'd say, well, this is 1 and 3. So we can multiply this and say this is 1 times 1, 3 times 4, 1/12, instead of saying 8/96 or whatever that ends up being. So we're going to do the same process of looking for common factors before we actually go through and multiply these. Because we could go ahead and multiply this and get this mess of a problem, which would be a cubic on top and a fourth degree on bottom, and then try and reduce everything, or we can do it beforehand, and the beforehand's a lot better for us. So if we go ahead and start factoring this, just like the first two problems, we're going to see there's a lot of common factors, so we kind of know what to look for, like I've been saying here. So if we reduce the numerator and the left side, x squared minus 16 is a difference of perfect squares. It factors into x and 4, x and 4, and because there's no b term or there's no x term, we know these are plus and minus, so those are equivalent. So now if we factor the denominator of this, x squared minus 4x plus 4, well, again, this one is a perfect square actually, so x and x, my factors of 4, 2 and 2, and because there's a plus in the back, that's the result of multiplying two numbers that multiply to be a positive have the same sign. These are both negative. So we made this into a lot cleaner form here where we can start looking for the factors. Now, top right, x minus 2. Conveniently, we have x minus 2 here, so eventually we'll reduce that out, but let's factor the denominator of this side as well. Factors into x and x. Numbers that multiply to be 8 add to be 6 because a is 1. Well, it looks like we're going to use 4 and 2. So there it is all the way through. So now we see all the different factors. This is just like rewriting numbers in a less complicated version. We can put parentheses around that. It doesn't really matter. So now I'm going to look for what we can cancel out here. So I see x plus 4. There's another x plus 4 here. So those reduce. X minus 4. No other x minus 4, so we're going to be stuck with that. X minus 2. We have an x minus 2 we can reduce out. And there we're out of factors that can reduce. So in the end, we can say this whole multiplication product, this is actually going to be 1 here, is going to be x minus 4 over x minus 2 times, well, what's left here when we divide is 1 over x plus 2. And now we go through and multiply this. So numerator times numerator, this is equivalent to x minus 4 times 1. So let's just write it like this actually. We'll do 1 times x minus 4 just so we have the constant in front. And then we're left with x minus 2 times x plus 2. We can go further in this and multiply it out if we'd like. We're not worried about values where this is undefined because there would be a mess of values that we'd look at. So if we really, really, really want to take this all the way, 1 times x minus 4 is x minus 4. X minus 2 times x plus 2, this is going to be a difference of two perfect squares, so it's x squared minus 4, and we're done at that step. So either of these will be okay, it just depends how far we want to take it and what we'd like to do with it. This shows all the factors, this shows the polynomials multiplied out. So there we have it, number 3.